Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week, I spoke with Savin Goyal and Hugo Bowne-Anderson from Outerbounds. They both work on leading, building, and helping people put models into production through Metaflow. And I'm sure some current users of ZenML will find this conversation interesting to hear how they think through the broader questions and engineering problems involved with MLOps. Above all, we spoke about the challenges involved in building a tool that handles the whole machine learning story, from collecting data to training models to deployment and back again. In many ways, it's great that there are lots of smart people thinking about this really hard problem, and even though it is by no means solved, conversations like this make me feel cautiously optimistic about the space. As always, all show notes are available at podcast.zenml.io, and I hope you enjoy the episode.
So we started Outerbounds, I believe, roughly 14, 15 months back. And to be honest, I totally sort of lucked into the space. So when I was starting my career 10 years ago, I was working at this ad tech firm where I found myself in this spot where, so I have a background in computer science. I did my undergrad in CS. But I was always sort of excited by more the mathematical aspects of computer science, the mathematical, logical aspects of computing. And in my very first role, I was kind of like this individual who knew a little bit of CS, knew a little bit of math, knew a little bit of data science. And then I was tasked with sort of being this glue layer between our team of data scientists and our team of software engineers. And we were essentially sort of building ad tech solutions, how to sort of target people with the right ad at the right time. And back then, there was no such role called as an ML engineer, so to speak. So I was sort of working in the era of big data and Hadoop and whatnot. So that's where I sort of got started in this particular space. Then after that stint, I went to LinkedIn, building LinkedIn's data mining infrastructure for their knowledge graph. And then after that, I came to Netflix, pretty much sort of working on similar set of problems for sort of more specifically focused on Netflix's own advertising efforts. And then a little bit sort of more deeper in the layer that, okay, how do we sort of build this infrastructure, the sort of glue layer between data scientists and software engineers, so that organizations don't have to sort of go out and search for sort of more humans in the mix. How can we make a data scientist more autonomous, more full stack in some sense? And then as sort of part of that, then we started sort of building tools. We open sourced a few. And then it seemed sort of the right time for us to sort of just leave Netflix and start building these tools just for a much more bigger audience. Because the appetite is clearly there. The world has significantly evolved from where we were, let's say, 10 years ago to where we are now. Hugo?
Yeah, so my trajectory is quite different, and I think it's fascinating how many different types of trajectories these days can end up in the same space, which is machine learning as a broad tent, because it speaks to, I suppose, all the different types of skill sets that we need in this space, and kind of the interdisciplinary nature of it. My background is in basic science research, so I actually went to grad school in pure mathematics, and I joke that 10 people read my thesis and 3 people understood it. So I wanted to kind of get into more applied math, the applied sciences. So I started working in, I did a postdoc in cell biology and biophysics in Germany. There's an incredible Max Planck Institute for Cell Biology and Genetics in Dresden, where I was for 2.5 years. And I worked with some of the most incredible scientists I'd ever met who did not have access to the tools and wisdom around using the tools that would help them do science as well as possible, right? They were generating large amounts of biological data, a lot from petabytes of data from microscopy and these types of things, right? And this was over a decade ago when the IPython notebook had just emerged. So I was using this, trying to help them analyze their data, design experiments, form hypotheses that we could test, and then analyze. And it became clear to me at that point that there was something very significant lacking in what we could call the tooling layer and the wisdom layer around the tools. Then I moved to the US to do more research in New Haven, Connecticut. And at that point, I started running workshops, which I called something like, practical statistics or practical data science for scientists, where I even found, tenured professors at Yale who really didn't have access to the tools or statistical techniques that they really needed. And at that point, I realized that I was kind of equally good at doing basic research and doing education, what we now in this space called evangelism or developer relations. But at that point, it became clear to me that something I could do and wanted to do more was help scientists do better science, whatever that means, right? And then I started working for what was then a small startup called DataCamp, doing things all across the board for building their curriculum, among other things. But at that point, it was an early stage startup, so I wore a lot of hats. After that, listeners may know Dask, which is distributed compute for the PyData stack. I started working with Matt Rockland, who developed Dask at a company called Coiled, where we were productizing Dask and distributed compute for PyData. The reason I decided to move in that direction was this was essentially, we're still going through it, but this was the beginning of, I suppose, an inflection point or phase transition where open source software served a lot of individual scientists and individual users, but it wasn't clear how organizations could adopt open source at large, right? And this is still a fundamental question we're working on at both Metaflow and Outerbounds. And so distributed compute, of course, is a fascinating challenge, particularly for me in the PyData stack, because Python is so close to my heart. But I really looked within and asked, what are the biggest challenges in the space, and where can the biggest impact be made? And operationalizing ML and productionizing ML for me was the most attractive because of the amount of impact that we all can have there, and the amount of kind of rich, interesting challenges and interesting people in the space. So I started chatting with people, kind of thinking more about the productionized ML space. I was introduced to Ville and Savin, who'd recently left Netflix to form Outerbounds, and one thing led to another. And we may get to this, I was very attracted to the open source framework, Metaflow, for a number of reasons. And both Ville and Savin were very explicit about how not only is evangelism and DevRel important, but it needs to be a foundational pillar for any open source framework. And them recognizing that just spoke to me so deeply that I jumped in 6 months ago and haven't looked back since.
So speaking of those challenges, I'm really curious, like where you situate the kind of the beating heart of the problem here, because it's not that tools don't exist. It's not that there aren't people by now with a lot of experience delivering things at scale or in production and so on, to obviously varying levels of success or reliability and so on. But I'm curious, like what's the core thing that you're working on, trying to solve at Outerbounds?
Well, let me kind of set the scene, and I think then Savin can dig deeper into a few things. I'll say a few high level things, but I suppose the first question is, what do we even mean by machine learning, right? And I don't think it just comes down to fit and predict and building specifically machine learning models. I think when we use the term, we're actually talking more generally about software that's powered by data in one form or another, right? And so the question for me from my scientific research is, what changes about software when we introduce the complexity of the real world into it via data? And one thing that's incredibly important within this, one key aspect, is that the skill sets of those involved change. We no longer have software engineers building software. We have scientists, which we now call data scientists, building software now. So the question is, people with very rich scientific backgrounds, scientific knowledge, who perhaps are very good at basic research and prototyping things, how can we enable them to rapidly iterate and move between prototype and production as quickly as possible? And I think one key concern there is iteration speed. So having said all that, I think Savin can drill down into a few of those things and speak to more as well.
Totally on point. And I think it's also important to realize that tools by themselves are not enough. At the end of the day, like there needs to be sort of like the strong wisdom layer, the strong sort of like layer of established patterns that guide people in terms of like, okay, what tools are the best for a particular situation? How do you sort of like, build a mental map of how to even go about achieving your objective? And I think that's sort of like the big missing piece that I still sort of like see. There are a lot of tools that sort of like help data scientists where they are. Like let's say if you want to just like pop open a notebook and do machine learning or data science within that. Of course, there are a lot of tools, but then depending on your definition of production, you could be sort of like staring at a lot of engineering work, a lot of engineering effort as well, which many times, like you may not even be trained for in the first place. So I think that's really important. And, like realizing that tools alone or education alone can't really fill that gap, and it has to be sort of like a good amalgamation of both.
Where do you stand on the kind of, I guess, possibly the non-technical struggles, like like what you were just talking about how you have this mixture now of data scientists working together with software engineers? Like, is your hypothesis that the data scientist either will be or should be able to do it all themselves without the software engineers? Should the data scientist become a software engineer? What's the kind of the scope of that non-technical bit?
Yeah, I think it definitely sort of like depends both on organizations as well as the projects that are involved. Of course, you would want to make sure that data scientists are able to do more and more by themselves without leaning on software engineers. And it can come in two flavors. One is sort of like, okay, do I expect sort of like my data scientists to be software engineers, or do I just provide them better tooling so that they can sort of like, just get more work done by themselves without sort of like wearing that software engineering hat? And I believe different organizations will sort of like, take different postures. Of course, there could be sort of like, let's think about problems, like that we saw regularly at Netflix and, back in the day at LinkedIn as well. There was usually sort of like a really high barrier in terms of introducing machine learning into sort of like any specific product. And that barrier was that, okay, like not only do we need to sort of like have one or multiple data scientists involved in this project, we also need to figure out that, okay, what is kind of going to be the engineering support for that? And then, of course, like you can sort of like make a lot of progress if you just lower down that barrier where it's easy to sort of like introduce ML into some specific problem. But then if you look at the other opposite end of the spectrum, like let's say recommendation systems that Netflix was building, they were at a sufficiently advanced scale that for many of the A/B tests that Netflix would run, you would need dedicated engineering support as well. And then, of course, there were projects in between as well, where we had individuals who had great software engineering skills as well, and they were able to sort of like take a project entirely end to end on their shoulders, and that was also providing a great boost to the bottom line of the company. So I don't think we can sort of like get to a point where there's one single established pattern that everybody will recommend. It's always going to be a mix. What do you think, Hugo?
Yeah, I totally agree, and I think identifying different cultural concerns is incredibly important. I think one aspect that we think about a lot is how data scientists work with machine learning engineers, right? And what that relationship looks like, and how that relates to other parts of the org. So, I mean, I think one way to think about it is to go through maybe like a general pattern for what going from, laptop or notebook to something production quality looks like, right? So I'll have a data scientist, and this is kind of to introduce different layers of the stack, prototyping in a notebook and a CSV. But then to go to production, they need to, integrate with a data warehouse or start to directly pull data from S3 every time a model is executed, or train on streaming data, right? So this is a question, kind of, there's a data layer in there which needs to be set up, and this isn't something that only a data scientist should own or be responsible for. We need engineering resources there, and we need some form of good information flow and cultural challenges solved for that to work, right? But then maybe you need to store your model and artifacts. Maybe every time you run it, in a data warehouse or a lake. So then we see there's a data storage concern, which you've identified, interacting with model versioning, which is another question. Then maybe your data volume grows and we need a larger instance, so we burst to the cloud. What happens to libraries then, right? How do you migrate your state? So we have all types of state questions and dependency questions, right? Then maybe you need to train on GPUs, but not for all your steps, maybe only for training, because GPUs are expensive, right? So then we kind of get this idea that I suppose workflows are a useful abstraction here. So we have something which maybe we initially saw in the data engineering space being relevant in the data science space. And the question is, I suppose, who owns all of these different parts of the stack, or who's responsible for them, and how people relate between them. So I think if we want to identify different parts of the stack, I mean, we've identified a few, from data to compute, orchestration, versioning, software architecture, model ops, feature engineering, model development, all of these. This is kind of going up the stack. The way we think about it, from a lot of conversations we've had with data scientists and the work we've done, is that data scientists are best served focusing on the top of the stack. So the model development, feature engineering, model ops, and then going down are things they care less about and that engineers care more about. So there's some sort of it's not binary, right? There's some sort of like double gradient of concerns and where people should be working. And so what we're really excited about is helping organizations figure out what type of best practices to adopt when using frameworks such as Metaflow, which help data scientists focus on the top of the stack, essentially.
Whenever I read or hear about this roles discussion that we're having right now, I think quite a lot about the kind of large numbers of people who are coming into this space right now, like new graduates, people who came from completely different domains, who are just learning about machine learning. Obviously, there's all of these kind of high-level frameworks which allow you to be dangerous quite quickly. And yeah, I'm interested, like, how, or whether you see the kind of a role in what you do in terms of education, setting standards, bringing together kind of consolidation in terms of how people do things, best practices. Is this something you think will kind of just emerge, or are you actively trying to kind of shape that as well?
I also have a few things. I think it's important for people developing tools and education around tools and workflows to set guardrails, but I think they need to be wide enough to give different types of organizations, different types of people, and professionals room to move. I mean, data scientists are the experts on what they need to do. You're right, there are a lot of top of funnel people coming in, and we need education and frameworks for them to stop them being dangerous. But in the end, we don't want to be constraining people or limiting people, I suppose. Particularly in a space where, as Savin said very clearly, pattern recognition, there is not just one pattern. There aren't just 10 patterns, actually, right? This is kind of a wild world of different types of questions, concerns, and technologies that we're still figuring out what the space looks like, right? And I suppose one thing I am excited about, and maybe Savin can speak more to this, is thinking about how we can learn from how and what we can learn from larger companies such as Netflix, right? And I think there is, and this is something I will push to Savin in a second, there is a myth that the things Netflix or Facebook or Apple does are so big and so at scale that and at such large global scale that they're not applicable to the rest of the world at all. And sure, maybe there are a handful of things these companies do that are like that, but there are a huge number of machine learning questions that have been solved by these companies that I think are applicable to the long tail. And what can we learn from these places as well?
Yep, totally agree on those points. Now, if you look at sort of like, the fact that a lot of people are now sort of like, looking at entering the space of data science and ML, of course, there's a huge demand. We need more and more of data scientists to enter this profession. Now, like, one of the hallmarks of success in this field, like what makes for a great data scientist in any organization, is definitely sort of like an individual who is great at data science, of course, but then they're also bringing in a lot of domain knowledge, a lot of business expertise as well. And at that point, would you really want your data scientist to be sort of like, focused on building depth in your business use cases, or sort of like, building depth on the engineering side of the house? That's a big question that many organizations sort of like struggle with. And ideally, these organizations shouldn't really be, in that sort of a dichotomy. And that's basically sort of like one of our founding principle, so to speak. That's how the team got started at Netflix as well, where if you look at sort of like, Netflix's use cases, of course, there's the tentpole use case of recommendations that everybody is sort of like, very familiar with. But then there are like hundreds of other use cases, which are like, small little tiny applications internally that do have a huge business impact. And we would call these sort of like business data science use cases, right? Like you can imagine, even before we get to recommend what content people need to watch, somebody needs to recommend internally to the content execs what content they should be buying or licensing, right? If we are doing, let's say, out of home advertising, let's say, there's a billboard that you see with sort of like an ad for a Netflix special, somebody needs to make a decision, and it is a data informed decision that, okay, which advertisement goes on that, just so that we can maximize awareness. Now, all of these problems are basically problems rooted in data science, and you'll find sort of like, either a single data scientist or teams of sort of like, 2 or 3 data scientists focused on solving these problems. And the data scale isn't really that immense. Of course, like at that point, you want to be really creative with the limited set of data that you have available to you. But then those problems are very much reflective of problems that any other organization would also face at that particular moment. And then the important thing at Netflix for us was that, okay, like if we have a data scientist who is really focused on increasing brand awareness of Netflix, or figuring out like, okay, what is the right pricing structure to recommend in different countries, then they indeed get the time to build up that expertise, to build up that business context. And they shouldn't be sort of like, struggling with that. Oh, like where is my data stored, and how do I deal with these Spark errors or Kubernetes issues and whatnot, right? So that was basically sort of like our focus, that let's just sort of like, hire the very best people who come with great data science background, give them the space to build up this business context, and then provide them the tools, and then get out of their way so that they can do their very best work.
I just want to give a specific example that kind of harks back to an earlier question about who should be doing what. And Savin mentioned Kubernetes, for example, right? And so the question is, should a data scientist be configuring Kubernetes clusters? And I think we can all agree the answer is most likely no. I'm hedging slightly there. I could make a stronger statement, but let's hedge, right? So you'll have an engineer configure that and sort that out. But then we need to figure out how a data scientist can leverage that cluster, right? So something I initially found very attractive about Metaflow is when you write a flow, you have a decorator, which is at Kubernetes, where you can get access for a step in your flow to whatever is provisioned. And this, to me, I could be wrong, we could be wrong, but seems like the right abstraction layer for data scientists to interact with our Kubernetes clusters, for example. Similarly with AWS Batch and whatever else it may be. But I suppose this speaks to how the cultural interactions best occur. And of course, there need to be conversations between data scientists, ML engineers, as to what type of clusters are necessary, how they work, and all of these types of things. But in the end, for a data scientist to be able to write a flow which they can run locally and prototype, and then merely attach a decorator to leverage compute somewhere else, I think that is incredibly useful and allows this iteration loop between prototype and production to be as tight as possible.
So it almost seems like you're maybe implicitly, and maybe I'm reading into that, there's kind of going back to this kind of idea of best practices, there's kind of a maybe responsibility is too strong a word, but some kind of a need for, or it's good if the framework nudges people in the right direction, has the API is designed in such a way that people take, broadly speaking, decisions which will benefit them versus harm them and the reproducibility of their model.
I love that. And I haven't thought of this in terms of nudge, but I like the idea of this being a nudge of sorts. And I mean, the classic example of nudge, right, is if you have a cafeteria, what do you put at eye level at dessert? Do you put the fruit or do you put the cake, right? And as it happens, people will eat more of what's at eye level. So that's kind of us designing something that helps them do something that we've all kind of agreed is good for them. So nudging them in that direction, but I suppose to make very clear, not decisions made by us in the abstract, but from years of conversations with data scientists and building tools for data scientists and building wisdom layers for data scientists, figuring out what the correct nudges are, I suppose.
Yeah. And then I think, while we are sort of like on the topic of analogies, like yet another way of sort of like, looking at this is when people look at adopting a tool, there's an immediate pain point that they are looking at solving. And there isn't sort of like any specific tool that will solve their pain point to the very 100%. There may be some cases, but by and large, that's never, entirely the case. And it's important to make sure that the framework is like a Lego block or like, Lego blocks of sorts, so that people can sort of mold it in a manner that sort of like serves their end use case. But then more importantly, what I found is that all of these frameworks need to be able to deliver a dose of vitamin over a longer term. They need to sort of nudge people, guide people to, okay, what are the best practices? And that's where those guardrails also come in, where, of course, we have built these tools for now decades. And there are certain patterns that are easy for us to bake into these tools so that people don't have to struggle with those. And then there are certain things that, are more kind of like best practices. And over a longer period of time, we'll see creative ways of how those best practices also get subjugated within many of these tools. And then there will be a newer set of best practices, more catering to the niche use case that people would be dealing with. So that's how I see the interplay between many of these tools, best practices, and these nudges versus some strong arm twisting as well at times to sort of like just instill good behavior.
What you were saying earlier about kind of, I guess, the repeated or kind of repeating use cases for ML, particularly in some business cases, reminded me a lot of the discussion around this concept of the modern data stack. And I'm kind of curious, what your take is on that, how machine learning fits into that as the kind of the next evolution. Maybe we had Tristan Zions from Continual on the podcast a few months back, and that was really interesting. But it seems like the transition into machine learning workflows that are repeatable and handle these kinds of use cases isn't quite there yet.
Yeah, totally. I mean, definitely, of course, the jury is still out there if the modern data stack is modern enough. But then when you look at sort of like, the raw ingredients that any organization needs to sort of like, start on their machine learning journey, it's sort of like pretty much in our face that you need some kind of data platform. You need a place where all your data is stored. You need to sort of like have a way of accessing that data. You need some place to sort of like run your compute, maybe sort of like it's a notebook in the cloud or notebook on your laptop, or maybe a Kubernetes cluster that allows you to sort of like, either do some data processing or train your models or run model inferencing and whatnot. And then as Hugo sort of like also pointed out, much of the activities in the machine learning universe, they also sort of like look something like a workflow. Like people want to sort of like, let's say, fetch my data from this data warehouse, process that data, generate some features, train a bunch of models, then do something with those models. And that's where there's sort of like a natural place for workflow orchestrators in that modern machine learning stack as well. And then as we sort of like, think about other use cases, if you can think about sort of like, model monitoring solutions come in as well. And maybe sort of like, there's a universe where sort of like feature stores fit in if, let's say, people want to share much of the work that's happening as part of these machine learning workflows. So by and large, of course, we do see many tools that are focused on addressing a sliver of the stack. Of course, you can go out and you can find sort of like, tools focused on distributed model training. You can find tools that are focused on experimentation management and whatnot. But then there is still sort of like a big problem for data scientists that, okay, how do they move between these stacks? Many of these layers are very mature. Some tools are sort of like, still seeking that maturity. But by and large, as an organization, once you're sort of like agreed that, okay, here are these sort of like set of tools or this stack so to speak, that we are going to deploy. How do you even move between the stack? How do we sort of like fill holes or fill gaps within the stack? That's a big missing element. And while there's a lot of conversation around the modern data stack, I think we are still sort of like too early on the machine learning stack for even a conversation on like, okay, what are the right constituents of the stack as well? And I think with like much of the work that folks at ZenML are doing, as well as us as well, I think that's really important to start having that discussion, so that even if, let's say, there's no single canonical machine learning stack that emerges over the next couple of years, there are at least some patterns that sort of like talk about that. Okay, here are certain things that are just mature enough for many organizations to sort of like just lift and shift and adopt for their own use cases. What do you think, Hugo?
I agree with all of that. And I'll build on that by saying, I mean, particularly for the data scientists out there who kind of are overwhelmed by the amount of tools, I just want to say that that's not only reasonable, but it would be unreasonable to not be overwhelmed. I think all we need to do is look at like Matt Turk's data and AI landscape, which actually I love it. I think he's half trolling as well. I think there's some sort of like, he's European, right? I think there's some sort of like deep like continental European satire embedded in that. But the truth of the matter is that we have a huge number of tools. The space is highly fragmented in a lot of ways, and we're trying to figure out what works for whom. And so when this happens, we can include this in the show notes if that works. But some time ago, I wrote an essay for O'Reilly Radar with Matt Rocklin about how we're putting more money, or like quote unquote money, our money on smaller interoperable tools as opposed to all-in-one platforms in the space, at least in the medium term. And so what we're really thinking about at Metaflow and Outerbounds is how can we develop tools that interoperate with what people use. So let's say you work for an organization where you use weights and biases, for example, for experiment tracking, or maybe you use Neptune, or maybe you use Comet, right? So suddenly there are 3 different things you can use for data validation. Use Great Expectations, or actually maybe use PyTest, or whatever it is, right? We want to make sure that a tool like Metaflow can interoperate with all of these and allow you to switch them in and out as easily as possible. And I think that's really important to recognize in the space at the moment. This comes down once again to when we're talking about pattern recognition, that there are kind of emergent patterns, but what occurs within the patterns are so various that we do need tools and education that help service all these different use cases, and all the kind of plethora of tools that people are using.
One thing I really wanted to ask you both about, because it's something I've been thinking a lot about myself, and also speaking with our guests here on the podcast about, is I guess like nominally or specifically about the kind of the role of annotation in all of this, but more broadly, when we start to think about kind of iterating over data rather than necessarily anything else, or perhaps model optimization and so on, how does annotation fit into all of this? How does annotation fit into to Metaflow? How can people, should this be part of the wider ML lifecycle, or is it kind of destined to continue to be this kind of black sheep in terms of, I don't necessarily always come across like too many data scientists who actually work on the annotation themselves, but increasingly maybe that's more of a thing.
I think definitely the adage holds true: garbage in, garbage out. So a lot more focus needs to be on data labeling tools. I think it's important to recognize that data labeling has become a lot more easier and accessible over the last few years. That was definitely not the case 5 years back, and it was really, really painful. And I think definitely, like when you're looking at sort of like iterating, or like thinking about like iterating in the concept of sort of like in the context of data science, it's important to understand that at the end of the day, all of these activities, like whether it's sort of like getting access to labeled data sets, building a model, monitoring models and whatnot, these are all sort of like a means to an end. At the end of the day, the goal of the organization is to deliver business value. The goal of all of these activities is to deliver that business value, and to treat sort of like labeling problems as sort of like as a holistic component of end-to-end machine learning lifecycle. That's really important. And I mean, we did sort of like start investing a little bit towards that, and during my time at Netflix, and hopefully sort of like, in the next few quarters, you'll see sort of like, more tools that will ship out, which will make it just easy for people to interact and integrate with many of these data labeling tools, and just sort of like, have a much more finer degree of control in terms of like what data is sort of like finding its way into their model training, model inferencing pipelines.
Yeah, I totally agree. Oh, and I just want to build on that by saying I think labeling is in such a woeful state more generally. There are so many cool technologies which we could adopt, and that people are working on that aren't hand labeling, for example. So even thinking about, semi-supervised learning, weak supervision, transfer learning, active learning, synthetic data generation, right? All of these things, I think, get humans in the loop in a far more interesting and productive way than purely acts such as hand labeling. And I'm glad you raised this, because this actually speaks to a broader point. I spoke with Peter Wang, who's at Anaconda, CEO of Anaconda, recently, and he said to me, Hugo, I want people to start using the term cybernetics again, as opposed to AI, because what we're really trying to figure out is how to get humans in the loop with computation. And I think this actually speaks more generally very nicely to what we mean by productionization, right? I think productionized ML, a lot of people use it to mean deploy to an endpoint, but I think this is unnecessarily limited and limiting in a lot of ways. So it's really about how, like, the degrees of automation. So two dimensions in productionization could be, automation, but in terms of production and in terms of consumption. So is it deployed to an endpoint or consumed by a human to inform decisions? In terms of production, is it a bespoke one-off analysis? Does it happen locally? Does it use cloud resources? What is the bus factor? These types of things. So I think this question about how humans are involved in annotation more generally speaks to a question about how we get humans in the loop when we productionize models. I do think this is something our head of data science said to me recently that I think probably both of you may find attractive and may think yourselves. The term productionization is so overloaded that perhaps something like operationalized is a better term, right? And the example Savin gave before of figuring out what to put on billboards, that isn't deployed to an endpoint, right? So is it productionized? I mean, maybe, depending what your definition of productionization is. We can definitely say it's operationalized, though, if it's informing human decision making. And doing stuff on billboards, like, I've never put stuff on billboards, but I presume it costs a lot of money. And actually, in terms of ROI for a company, it's highly impactful. So not only is it an operationalized model, not deployed to an endpoint, but it's one that's probably a very important decision to be made.
Yeah, for sure. And I mean, certainly the annotation space is kind of booming in its own way, a little bit similar to what's going on in the MLOps world. And that you could probably make an equally complex and disorienting diagram of all of the annotation tools and all of the capabilities that they exist. So there's probably a lot more kind of churn and things to come out of that in the future.
Yeah, I mean, in many ways, more options. That's a better spot to be at than compared to, let's say, 5 years ago when you had to spin up your own mechanical Turk campaign.
Yeah, for sure. Yeah. Another kind of black sheep in a similar area, in fact, maybe following on from what you were talking about, Hugo, in terms of communicating and kind of surfacing insights from whatever you're doing as a data scientist, is the area of documentation. And I certainly would be remiss not to take the opportunity to ask about all of the things you're doing with MBDev2 and documentation and Dockersaurus and so on. I was hoping maybe you could talk a little bit about documentation in machine learning in general. Like, is this another thing like annotation somehow? I know with Metaflow you've got DAG cards or model cards. You've got some kind of cards. could you talk a little bit about documentation and how to do that correctly?
Yeah, I will say, you've asked a bunch of really interesting questions in there, and I think we've already overloaded the term documentation, right? In terms of API documentation, framework documentation, education around tools and wisdom layers, and then documenting models, which Metaflow cards I find incredibly interesting and attractive for that, in order to visualize all different aspects of your models. But the first thing I'll say is that I think documentation is one of those things that is almost invisible when it's good, but when it's bad, you hate it. I mean, it hurts, right? Like you're trying to build something, and you're using docs. They're actually for a different version of the software that it doesn't explicitly tell you about. Suddenly, you have to watch a video on YouTube. There's no code to copy and paste. A lot of the time, you got a Stack Overflow. I mean, the advent of Stack Overflow, I think, in a lot of ways, is due to poor documentation, right? And the popularity of Stack Overflow, right? So I think that is very much worth being explicit about, that it can be huge, serious paper cuts when documentation is poor. On the other side, I'm not criticizing anybody, because building good documentation is one of the biggest challenges in software, as far as I'm concerned. On top of that, not only building it, but having tools that allow you to build documentation super quickly. So that's why NBDev 2 is, for example, and the stack that we're using has been pretty exciting for us, because it allows us to make sure we have reproducible documentation that runs through a bunch of essentially CI tests every time we build it, to make sure it works, that anytime someone reads it with whatever version of Metaflow they have, it will actually work. So that's something I'm very excited about. And you may have seen we published a blog post about the stack yesterday, which we can share in the show notes as well.
Yep. Yeah, I think there are sort of like, three distinct classes of documentation that we are sort of like primarily concerned with at this point. So one is that, okay, how can sort of like a data scientist document their own work for their benefit or for their peers' benefit? And, like when you look at sort of like features like Metaflow cards, they're sort of like step in that direction. I mean, the reality is that people should be spending a lot more time than they are today documenting their work. And we want to lower that barrier as much as possible by providing automated tooling, so that they don't really have to struggle with tools at that particular point. So the only struggle at that point would be sort of like, putting coherent thoughts on paper. Then the next kind of documentation, which sort of like, harkens back to this productionization concept as well, is that how do you communicate your work to your stakeholders? And that could indeed be sort of like, one dimension in which you're productionizing your model. Maybe you're writing a memo that talks about, some analysis that was driven by some machine learning model, and you're presenting it to your business stakeholders, and you would want to make sure that that's something that's articulated well. If, let's say, this is a model that trains frequently or that updates frequently, somehow your documentation can also sort of like, update alongside with that, with sort of like minimal effort from your side. So that's sort of like, clearly important for us as well. And there are like many features that we are building in that particular space too. And then more importantly, at the end of the day, for us, the role is not to sort of like, just build this tool called Metaflow. We want to make sure that we are sharing our knowledge with the wider community as well. And internally as well, there is sort of like a huge focus for us to be able to sort of like share this information, share this knowledge as broadly and as easily as possible. So we need to sort of like be really good at putting our money where our mouth is, and really sort of like investing in first-class documentation infrastructure, so that it's just easy for us to scale out those efforts.
So we're all building in this open source space, and we're kind of moving forward in public and so on. I kind of wanted to ask the direct question of kind of why, or I guess you don't believe this, but what's to prevent, the one platform to rule them all, suddenly making all of us obsolete, whether it's, I don't know, some Databricks type platform or SageMaker or something like this? Is it the the complexity of the use cases? Is it the fact that no one knows what the end state is at the moment? So,
have you used SageMaker? I'm just joking. I'm not half a joke, right? But Savin, perhaps you can start. And
Yeah, no, I mean, like the space of machine learning is huge. And I mean, if you look at cloud computing, right, like is there one platform that rules everyone? Sure, like, like there's one company that has sort of like significant market share, but then there are many other healthy businesses as well. And it's very likely that we'll come across sort of like, let's say 3 years from now, 5 years from now, we'll be at a spot where there are maybe sort of like, two big players, and then there are like many other companies as well building sort of like, really successful businesses. Even in the data platform space, I mean, of course, like there's Snowflake and there's Databricks, and then there are like many other companies which are, part of the modern data stack, the modern data movement as well. And many of those will build flourishing businesses too. So from that point of view, I think the most interesting and exciting thing for me personally, and the reason why I started this company was that people are still figuring out what works, what doesn't work. That's really exciting. In many ways, the rules are being written as we speak. The patterns are being established, and it's really interesting. As sort of like budding open source projects, to be together on this exploration. I think that's the most interesting part. Hopefully, 5 years down the road, we can look back and we can sort of like, be confident that there was some positive contribution that we made to the overall velocity of machine learning adoption by and large.
yeah, I agree with that completely. And to build on that, I think a short bit of history may be insightful. I'm not certain, but I think we can all agree that the PyData stack, and by that I mean your NumPys, SciPys, IPython, Jupyter, Matplotlib, all of these things have started to really dominate the space in a very serious way. So much so that they're foundational and canonical now for a lot of the work we're talking about. So let's think about how they emerged. And they weren't built by big companies. They weren't built by computer scientists. They weren't built by software engineers. They were built by people, for the most part, working in academic research or in jobs where they needed. I mean, Wes McKinney built like Pandas Read CSV because he really needed it and was sick of hand rolling stuff, right? At the same time, John Hunter was working on Matplotlib for similar reasons. Fernando Perez built the IPython kernel when he was working in basic science, right? On top of that, there were communal network effects. And we're actually now talking about something that is almost, these open source communities are generative communities that are almost antithetical to the type of corporate incentive systems that we're discussing when talking about the building of these big platforms. I'm not actually saying one's better than the other. They have a lot of different affordances and a lot of different downstream results. But what we have here is a recent and very relevant, incredible example of how open source can serve the needs of actual practitioners because it's built by those communities and they're meeting in person to figure out how to interoperate them. So I'll give the example. There are lots of kind of communal network effects there, but early on, Wes McKinney considered John Hunter, who was working on Matplotlib, a mentor, and he would visit him to figure out how to get Pandas and Matplotlib interoperating together, right? So I think considering that narrative in terms of this space, the ability of open source to, I think, serve the needs of users and a community cannot be dismissed. Now, there's a slight, I think, addendum to that, which is we can think about, I've been talking about community-backed open source and not company-backed open source, which we may need a different term for. All we need to do to think about that is look at the raging success of PyTorch these days, right? Which is not a community effort in the way I've just described. It's company-backed, but yet it's been able to serve the needs of users because of how they've prioritized community-led development as well.
Since we're talking about kind of the way things are going, somehow I wouldn't necessarily ask you to gaze into the crystal ball, but I am curious what kinds of things you're looking at or watching to see to be able to judge in what direction things are going, if that makes sense. It's a slightly different version of the question.
Yeah, I think this is something that in the end is eminently not scalable at these stages. I think we need to speak with as many data scientists as possible, perform some sort of pattern recognition, rank order what seems to be as important as possible, check our biases. I'm very interested, in all honesty, in not only speaking to, I spend a lot of time speaking with Metaflow users. I want to find more people who've considered Metaflow and decided not to adopt it, to figure out how we can service them. I do think also checking some form of network effects in terms of once, let's say, not to mention any names, but once a big company in a particular vertical adopts Metaflow, for example, there may be several others in that vertical that follow, and it would be easy to overfit to that particular vertical. So always checking that and making sure that we're considering the needs of people across as wide a spectrum as possible. So I think at a high level, that answers your question, but maybe Savin can drill down into some specifics.
Yeah, I think, what's really important for us is that whatever we are building, it addresses actual problems that our end users are running into. And then the best way to sort of do that would be to continuously engage with folks who are using our tools, who are not using our tools, and really sort of understand that at the end of the day, there is some science to it that, of course, the more the number of people that you talk to, the more information gain you have. But then by and large, great product management is still sort of like a big art. And of course, we make our own mistakes. We have our own sort of big wins at times as well. And the more we do it, the hope is that will sort of continuously allow us to guide in the right direction and just build better and better product. We haven't sort of relied on up until this point any sort of specific quantitative metrics, because it's really difficult to sort of optimize for any of those. So it's mostly qualitative assessment that we are sort of seeking at this particular moment.
Mm-hmm. So we usually end with a couple of kind of quick fire questions. Maybe you could both give a stab at them. You can answer them or take them in whatever direction you feel is appropriate. The first one would be, what would be a quick win that someone can add to make their productionization or perhaps operationalization of models more robust?
I think the quickest thing would be to sort of really understand what is the definition of productionization in your use case. Maybe you don't need a super strong SLA for your model serving endpoint. My favorite example is actually Netflix recommendations. A bulk of those Netflix recommendations are pre-computed recommendations, because those recommendations don't change minute over minute or even hour over hour. So really sort of understanding what is the business context, what is the business use case that can simplify the problem significantly. And I think that's the first step towards robustness.
I like that. And I'll kind of mention something at the other end of the process, which is, this is downstream, right? But answering the question is, if I went on PTO for a week, would it be reproducible? Does it have a bus factor of more than me? Can someone else keep this? If I shut my laptop, will it keep going?
If I can add to that, I think most ML projects don't even have a bus factor of 1, in the sense that if I shut my laptop and then if I sort of open it back again, can I even re-execute the entire code again to get similar results? I think we still
sometimes I don't even have to shut my laptop; it just stops.
Yeah, exactly. So I think many of those projects definitely they should sort of think about reproducibility or rerunnability as sort of a core ingredient. Because if you don't have that, then you lose out on many of sort of significant advantages that many other software engineering tools can even provide for free at that particular point, right? If things fail, can't even rerun it again to get back to the same error. How are you even going to debug it and fix it and sort of move on? So,
and I think a lot of let's say intermediate, middle funnel data scientists. Sorry, I sometimes wear a marketing hat. Apologies to anyone who's offended by being classified as a middle of funnel data scientist. But if you're just getting going and trying to figure out what type of like software principles to think about, I'd definitely look into learning a bit about versioning, both versioning code, versioning models, versioning data. Refactoring code is incredibly important as well. And then thinking about data testing and data validation and software testing, which is related to those two. But if you kind of can get a handle around these three things, I think there's some Pareto law, right, where that gets you like X percent of the way.
Mm-hmm. Yeah. And what would be one part of kind of putting models into production that you think needs to be given more attention by tool makers in the MLOps space? Maybe that's just your roadmap. But
No, I mean, good question. I mean, I do see sort of like, like many tools in this space that are sort of like targeting different definitions of deriving value from machine learning. So if you look at like companies like OctoML on one end of the spectrum to sort of like, all the way to BentoML to sort of like, spin up an API endpoint. I think the big thing to really sort of like understand here is like, when we are talking about, let's say, the model hosting space specifically, there is no one size fits all solution out there, right? Like the kind of SLAs, the kind of scale that you need to, let's say, host an endpoint that is servicing an internal application could be very different than, let's say, you want to sort of like build something that can take the onslaught of like, tens of thousands of QPS and can provide you, let's say, 5 nines of uptime. And having that distinction is really, really important. You can't sort of like, just say that, hey, here's a model hosting solution and just roll with it as if, it's sort of like a silver bullet that can solve all your pain points. So I think over sort of like a longer period of time, my hope, my expectation is that people will sort of like naturally understand this distinction. It's the same with databases, right? Like there's no one single database that can solve all your use cases. All of these databases come with different trade-offs, and really understanding when you're choosing a tool, what trade-off are you making? That will go sort of like a long way in being happy with the tool. What I see more often happening is that people enthusiastically adopt a tool, not really understanding what are the scenarios for which that tool was never designed in the first place. And then when they start using that tool for that particular scenario, that's when disappointment sets in. And that's never sort of like a good thing for anybody.
Part of what I'd like more of, and not as well, because it's part of Metaflow's unique value proposition, as far as I'm concerned, is people thinking more about storing and accessing all artifacts from the training of models and all parts of your machine learning workflows. Actually, one of the first times I encountered Savin was on a podcast where the interviewer kind of spoke about it as like, you can take snapshots in video games, which you can return to. So having access to everything at any point in time and having them easily accessible. I think the world of experiment tracking is wonderful and solves a lot of real concerns for data scientists. I do think they're downstream of other concerns that we're trying to solve as well. So having access to all artifacts in an easy to retrieve manner is incredibly important to me. The other space, which is I suppose adjacent, but part of these workflows, is I mentioned PyTest and Great Expectations, but data validation more generally and data testing. I'd love to see more movement in that part of the space, because it's so incredibly important, and it's so nascent for the space as well.
Yep, I would agree with all of the above. So yeah, thank you very much for both for coming on all of our respective time zones. It's definitely super fascinating for me, like to speak to other people like knee deep in the same space. So yeah, and I wish you all the best for the work that you're doing as well.
Thank you.
Thank you for having
thanks
us.
for such a wonderful, thoughtful conversation as well, Alex.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.